On to cutting out all of this material on the inside. Now, looking at this part, that's going to be the most time consuming. So if you had a production run, I might not do it the way that I'm talking. If anything, I may think about true milling, which is an option in Surfcam. I don't think it comes with the demo mode. Maybe it does. Let's see. No, if your company offers true mill, we will have a lesson on that. But during this tutorial, I will not provide that because most of your licenses that you will be buying from Surfcam will not come with true mill. I believe that's a separate thing that you have to buy. So for now, we'll just use the pocketing feature. So let's go ahead and delete this toolpath. If you right click and go to delete, and you delete this, it does not delete it out of the operation manager. It's still in there. We will need to turn our masking on for red lines, and that will be all of these diameters and this outer red line. Now the reason I offset this line so dramatically beyond the part is because it needs room for the end mill to go around. So if the end mill is a 1/2 inch end mill, it will need to at least be a 1/2 inch plus away from your part. So there will be a little bit of cutting air, but again, we're just making one part and we're trying to get this done. So I want to show you the pocketing feature next. Our masking is on. So let's go to NC 2-axis pocket. Everything visible. Our visible is not here, so we have to go to auto, then everything visible. Done. We will be using the exact same tool, so 1/2 inch end mill, tool 3. And notice it kept all of my same settings. So that is one cool feature about Surfcam, is it will keep your same settings. So on the inside of the pocket, because we will be plunging into straight material, which we won't just plunge in there, we will helical first. We want to change a few of the feeds and speeds. We can bump this up on the machine as we run it, but for now let's just feed 30. And plunge rate, the plunge rate is important because that's what we will be helicaling at. So the helical feed rate will also be different than the actual feed rate because it will be the plunge rate. So let's helical at 15. 1/2 inch end mill. Alright, all that looks good. And again, you want to plug something in here that you know is going to work. And while you're listening to that end mill on the machine, you can bump it up or slow it down. So let's go to cut control. We're going to be climb cutting. The pocket cutout mode. You have spiral, zigzag, and zig. We're just going to leave it at spiral. I've never been in the situation where I had to use zigzag or zig. I've always left it at spiral. Alright, you do not have to worry about any of these settings except for top. But I'm going to go ahead and leave it at top, and then I want to show you the difference between top and bottom. Alright, taper angle, we'll use that one later, but not right now. So the Z depth is one thing we forgot to check, but for now, let's go ahead and plug in a number. We'll say 750. And we're going to take this full depth, 750. Actually, let's take that in 2 steps. Alright, rough spacing. Now you'll notice that it does not allow you to choose the amount to remove in X and Y. And that is because it automatically does the math. So if my rough spacing was 0.3, it throws up an alarm basically telling me that there will be spots on the bottom surface that will be uncut if I did 300 thou spacings. So it's saying the minimum value is 225, so I hit yes. Alright, we do not need any finish passes because we are roughing. Finish spacing, we will go into more finish passes whenever we program the finishing cycles. Stock to leave, we do want to leave stock in X, otherwise it'll be finishing those diameters, those studs sticking up, so we want to leave 8 thou. And we definitely want to leave stock in Z, so we're going to leave 15 thou. And I like to leave a little bit more stock in Z in case you had an end mill break or something like that. That way it wouldn't gouge your material. If you're really scared, you might want to leave 20, but 15 should be just fine. Lead in move, we will put an arc on. Same lead out. change it to feed. We'll go to constant, and we will say 50 thou. And that is everything that we need to change for pocketing this out. Now let's see how it looks. Now there will actually be a few issues because we don't know the depth and we have it set on top, so I'll explain that. I'm going to hit OK. Now it's saying select inside of the pocket. Click in the middle and we'll hit accept. Now you'll notice it's way down here, and that's because top, whenever it's selected in here, goes from the very top of the geometry down. So from the toolpath to the geometry is 750 thou. Let's go ahead and measure the distance that we actually have to cut. Alright, the masking is on, so we need to turn that off. The center of that to the center of that. So we got the great number of 666, so should be easy to remember. So I hit escape, go back to the operation manager, and we will change that to 0.665 because I am superstitious and I do not want to run a machine with 666. So we're going to change that to 665, and all I did was go 0.665 divided by 2, hit tab, and everything looks good. So all we have to do now is go to bottom, and what that will do is it will go to the geometry and stop. So everything that we programmed in that Z column is from the geometry up whenever you hit bottom, but when you say top, it will take everything from that geometry and go down. It's a little tricky at first, but once you understand how Surfcam thinks, it's very easy. The other two we will go over later. That's most of the time all you're going to be using is top and bottom. So bottom Z and top Z. There has been occasions where I've had to use bottom Z, but you will not be using those on a day-to-day basis. Alright, so that is our roughing cycle. Now there will be some funky movements here and there. So you'll notice that it hits these sharp corners. So there is a way to avoid that. So let's go back into our options. And we're going to enable high-speed machining and give it a minimum radius of, let's say 30 thou. And a maximum radius of, we'll leave it at 1 inch. Hit OK. And notice it turns those sharp corners into a radial move. Now the very last thing that I forgot to do, which we'll go into right now, is heligling into your material. As of right now, it's just plunging straight down into 300 thou. So we need to go back into our options. In the plunge type, you can peg, but I wouldn't suggest doing that in still. Let's go to helical. It's way better on the end mill. I only changed 2 numbers on this entire thing just to kind of make it easy for you, and that is radius and pitch. Whatever I make my radius, I'll divide that by 2 in the pitch. And it's as simple as that. How I adjust my helical is I'll hit OK and visually look at where it's helicaling. So it's doing it right here, and I'll see, and this rule mainly applies whenever you're helicaling into a hole to make sure that it's not too small, because you always want to helical as close as you can to the diameter. That way it's a light cut at the very bottom, which we will go into later. For now, that helical looks just fine. So it's going to start helicaling down about 300 thou, then it will start pocketing all this material out. Now we can move on to finishing the bottom of the pocket, the profile, and also adding a drill mill on all these edges so we have a nice little chamfer, and then we will go into 3D'ing this chamfer.